The following unit will be engaging students in understanding coding through creating algorithms. The life cycle of a frog will be used as a platform for students to practice coding and engage in computational thinking. Throughout our unit plan, students will be able to speak and structure their thinking in a way that the computer understands it, which within this digital age will be a key skill to possess. When organising the algorithms in a way that the character completes the prescribed steps, students will be faced with logical thought processes and will have the ability to problem solve and spot mistakes through coding. These basic computational thinking skills will encourage a way of thinking that will be beneficial to children in their everyday life. Students will come across initial barriers in the first lesson and will have to apply problem-solving skills when creating and coding their first actor. We know that students learn effectively through the combination of words and pictures rather than only through text. Therefore, by having students manually navigate Tinker to create their characters and position the visual code blocks, students can better understand the digital literacy process. In addition to this, computational thinking is being facilitated when students are decomposing the example algorithm given in Lesson 1, taking that complex problem and breaking it down into a series of small, more manageable problems. Students are then learning pattern recognition as they are looking at this algorithm and considering how they can apply it to the other actors, making it relevant for various circumstances. To learn coding through a multimedia resource, this will help them process the information into a long-term working memory. Through this visual programming, it is allowing students to rapidly transform ideas into actual programs by connecting these different blocks. At this stage of the unit, students will be adding sound and text. Using their developing computational thinking skills, they will be creating an algorithm that instructs the actor's sound. By incorporating the audio and visual aspects of the lesson, this approach can be differentiated to engage students of all abilities. By adding in another layer to this unit, students are continuously challenged to develop further computational thinking through advancing their coding skills. The use of audio and visual makes it possible to present their computational thinking in different ways and enables different forms of interaction with learners. Students who are confident in the tasks set by the teacher can be provided with extension activities. These would be useful to create different levels of computational thinking through a multi-level approach to coding. This extends the students' abilities and challenges them to understand the mechanism of algorithms, as in order to change the algorithm, they first need to understand what it is made up of. Another benefit of this unit plan is that it uses a learning area of science to teach coding. This is not an abstract subject being taught through an abstract program. This is a topic that they have been focusing on in science and using coding to instill this information. It is important for the teacher to provide real-life examples or connections that put the concepts into an easily comprehensible perspective. In relation to this, in the first lesson when describing algorithms and what coding is, we believe that the concept will be best grasped through real-life descriptions. A visual flowchart will be a tool in explaining what an algorithm is and will assist problem-solving skills. This relates to STEM's perspective of design thinking, as the students are engaging in designing and testing the algorithm and working through a visual flowchart. It will give students a guide on how to tackle complications by revisiting and reprogramming aspects of the algorithm to correct them. This unit can be extended in exploring other life cycles to continuously develop and advance the students' coding, which will be efficient in providing long-term computational thinking.